Assalamualaikum dan salam sejahtera. Yang berbahagia, Profesor Dr. Muhammad Roslan bin Sulaiman, Naib Chancellor Universiti Putra Malaysia. Yang berbahagia, Profesor Kemis Dr. Muhammad Basharuddin bin Abdul Rahman, Dekan Fakulti Sains. Yang berbahagia, Profesor Kemis Dr. Azah Yusof yang akan menyampaikan syarahan inaugural pada pagi ini. Para penonton yang dihormati sekalian, selamat datang diucapkan kepada semua yang menonton majlis syarahan inaugural oleh yang berbahagia Profesor Kemis Dr. Azah Yusof. Untuk makluman semua, majlis syarahan inaugural ini diadakan secara dalam talian dan dipancarkan melalui Facebook UPM dan Facebook Fakulti Sains. Anda dialu-alukan untuk menekan butang like dan share pada halaman Facebook tersebut. Seterusnya, bagi memohon keberkatan majlis pada hari ini, majlis mempersilakan Dr. Muhammad Hanif bin Wahid untuk membacakan doa. Dipersilakan.
Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin. Wassalatu wassalamu ala ashrafil anbiya'i wal mursalin wa ala alihi wa ashabihi ajma'in. Ya Allah, Ya Rahman, Ya Rahim. Ya Allah, di kesempatan ini kami menadah tangan ke hadrat-Mu. Sesungguhnya kami memohon kepadamu rahmat dari sisimu, yang dengannya Engkau memberi petunjuk kepada hati-hati kami, yang dengan rahmat itu Engkau memudahkan urusan-urusan kami, yang dengan rahmat itu Engkau menjauhkan kami dari kesusahan, yang dengan rahmat itu Engkau memperelok segala urusan kami, yang dengan rahmat itu Engkau meninggikan darjat kami, yang dengan rahmat itu Engkau mensucikan amalan-amalan kami, yang dengan rahmat itu Engkau memelihara kami dari sebarang keburukan. Ya Allah, berkatilah majlis kami ini dari awal ke akhirnya. Kurniakanlah kami ilmu-Mu. Sinarilah hati-hati kami dengan cahaya hidayah-Mu. Kurniakanlah jua kepada kami kesihatan, kecergasan akal fikiran, ketenangan jiwa dan kekuatan semangat. Semoga dengannya kami mampu berdepani cabaran, berdaya saing dan mampu mengangkat martabat diri, keluarga, masyarakat dan negara. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar. Wa sallallahu ala sayyidina Muhammad wa ala alihi wa ashabihi ajma'in. Walhamdulillahi rabbil alamin.
Amin, amin, amin ya Rabbil Alamin. Hadirin yang saya hormati sekalian, majlis dengan segala hormatnya mempersilakan yang berbahagia Profesor Dr. Muhammad Roslan bin Sulaiman untuk mempengerusikan majlis syarahan inaugural dan seterusnya menjemput yang berbahagia Profesor Kemis Dr. Azah Yusof untuk menyampaikan syarahan beliau. Majlis dengan segala hormatnya mempersilakan.
Terima kasih saudara dan saudari pengacara majlis. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Yang berbahagia Profesor Dr. Muhammad Basharuddin Abdul Rahman, Dekan Fakulti Sains Universiti Putra Malaysia. Yang berbahagia Profesor Azah Yusof yang akan menyampaikan syarahan inaugural pada pagi ini. Pegawai-pegawai kanan Universiti Putra Malaysia, ahli pengurusan fakulti, tetamu-tetamu jemputan, rakan industri, para staf dan pelajar, sidang penonton yang dihormati sekalian. Alhamdulillah, syukur kehadrat ilahi kerana dengan limpah kurnianya, kita masih lagi diberi peluang untuk bersama-sama pagi ini bagi meneruskan usaha memartabatkan kesarjanaan ilmu. Terlebih dahulu, izinkan saya memperkenalkan yang berbahagia Profesor Dr. Azah Yusof. Profesor Dr. Azah Yusof yang dilahirkan pada 24 Oktober 1973 merupakan seorang ahli akademik terkemuka di Universiti Putra Malaysia. Beliau memperolehi sarjana muda dengan kepujian dalam kimia dari Universiti Kebangsaan Malaysia pada tahun 1998. Dan kemudiannya memperolehi ijazah kedoktoran dalam kimia analisis dari Universiti Kebangsaan Malaysia pada tahun 2002. Pada tahun 2008, beliau mengikuti pengajian pasca kedoktoran di bawah Profesor Lisa Hall, Institute Biotechnology, University Cambridge. Beliau dilantik sebagai pensyarah di Jabatan Kimia Fakulti Sains pada tahun 2002. Pada tahun 2013, beliau memperolehi jawatan profesor pada usia 39 tahun dan dilantik sebagai Ketua Peranti Fungsian di Institut Teknologi Termaju ataupun ITMA. Pada 2015, beliau dilantik sebagai Pengarah Institut Teknologi Termaju ITMA. Beliau terkenal dengan pencapaiannya yang mengagumkan dalam pelbagai cabang akademik. Penyelidikan beliau telah menghasilkan lebih daripada 200 artikel jurnal. Artikel beliau telah dipetik sebanyak 5,000 kali oleh penyelidik antarabangsa termasuk penyelidik terkemuka dalam bidangnya. Kepakaran beliau dalam bidang sensor membolehkan beliau dipilih sebagai editor oleh pelbagai jurnal antarabangsa. Profesor Dr. Nur Azah mempunyai 10 paten kebangsaan dan antarabangsa. Beliau juga merupakan penerima grant penyelidikan dalam jumlah hampir ringgit Malaysia 10 juta pembiayaan dari pelbagai sumber dalam negara dan luar negara. Beliau telah menerima grant Newton Fund pada tahun 2015 dan telah bekerjasama dengan University Anglia Ruskin, United Kingdom untuk projek mobile-based TB detection, di mana dari hasil kerjasama antara kedua universiti telah berjaya menghasilkan aplikasi untuk pengesanan tuberkulosis atau TB yang lebih mudah dan berkesan. Beliau juga menerima grant dari industri seperti Nano Malaysia Berhad bagi beberapa fasa untuk tujuan pengkomersialan sensor TB yang sedang menjalani fasa klinikal yang kedua. Beliau juga bekerjasama dengan industri seperti SG Solution Sdn Berhad, Upstream Downstream Sdn Berhad yang merupakan pembekal servis utama bagi sektor gas dan minyak bagi tujuan penyelesaian masalah merkuri dalam produk minyak dan gas di Malaysia. Hadirin yang dihormati sekalian, Profesor Dr. Nur Azah telah membimbing lebih daripada 40 orang pelajar siswazah. Beberapa pelajarnya kini berkhidmat sebagai ahli akademik dan penyelidik di institusi penyelidikan, universiti dan industri. Hasil daripada pencapaian kecemerlangan, beliau telah dianugerahkan sebagai Top Research Scientist Malaysia untuk tahun 2012 dan anugerah Fellowship Naib Chancellor di bawah penyelidikan dan inovasi pada tahun 2017. Dengan minat yang mendalam, beliau mula bekerja pada sensor kimia optik untuk pengesanan logam toksik untuk kajian PhD beliau. Beliau seterusnya mengembangkan kepakarannya dalam biosensor berasaskan elektrokimia dan optik untuk pelbagai aplikasi dalam diagnostik perubatan, pemantauan toksik alam sekitar, pemantauan kualiti makanan serta penderiaan berkaitan pertanian. Beliau telah mengusahakan biosensor berasaskan DNA dan biosensor berasaskan protein selama lebih daripada 10 tahun. Beliau juga sedang giat mengusahakan bahan nano untuk meningkatkan prestasi elektrod dalam penderia elektrokimia. Beliau juga menjalankan penyelidikan polimer cetakan molekul atau MIP selama lebih daripada 10 tahun dan membangunkan penderia berasaskan MIP pada projek penyelidikan terbarunya. Untuk mengakhiri kata, saya mengucapkan syabas kepada Profesor Dr. Azah Yusof atas segala pencapaian dan kejayaan beliau yang patut dicontohi oleh semua ahli akademik di universiti ini. Sekarang, marilah kita mendengar syarahan inaugural oleh Profesor Dr. Azah Yusof yang bertajuk Biosensors and Chemical Sensors, Sense and Sensibility. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Ucapan terima kasih kepada Yang Berbahagia Profesor Dr. Muhammad Roslan bin Sulaiman, Naib Chancellor Universiti Putra Malaysia. Yang Berbahagia Profesor Kemis Dr. Muhammad Basharuddin bin Abdul Rahman, Dekan Fakulti Sains Universiti Putra Malaysia dan sidang hadirin pendengar sekalian. Saya dengan ini memohon keizinan Yang Berbahagia Naib Chancellor Universiti Putra Malaysia untuk meneruskan syarahan ini dalam bahasa Inggeris. I'll be sharing my experience for the past 20 years in development of biosensors and chemical sensors. I am among the pioneers in research in biosensors and chemical sensors in Malaysia, as well as in Department of Chemistry, Faculty of Science, University Putra, Malaysia. So let me introduce to you what is sensor technology. Previously, we are used to having samples bring to the lab and analyzed by big instruments. But nowadays, people are more used to portable devices. We are used to glucose meter as well as DIY rapid test kit for COVID-19. But in the near future, we are going to have implantable sensor, wearable sensors. And nowadays, you are familiar with Vital that you can look at your smartwatch or smartphone. But in future, you can have a real-time reading of your glucose level, and complicated diagnosis can be done in smart glass or wearable. Even your clothes or even the toilets can tell you, can give a good diagnosis of any diseases. What we have here are examples of biosensors that currently in the market. As you can see, Siemens, Nokia previously produced handphones, but they are now focusing on producing medical diagnostic devices. You can see there is sensor in the size of credit card, and at the right side you can see implantable or wearable sensors developed by DARPA. So DARPA invests 7.5 million for implantable biosensor tech for the purpose of security. And this is the latest one for COVID-19. This is based on CRISPR technology. As we know, CRISPR technology has won Nobel Prize in 2020 under chemistry. This is a collaborative work between Wyss Institute for Biological Inspired Engineering at Harvard University and MIT. So this is a wearable mask which can detect COVID-19 at site in a very short time. Apart from that, we have eNose. The commercial name is Spironose, developed to detect COVID-19. As you can see, this will actually help to avoid from taking samples which is actually painful from your throat as well as from nose. So thanks to the development of biosensors, diagnostics in medical are much easier compared to previous technique. Okay. So this is smart underwear. So on the battlefield of tomorrow, your underwear could save your life. So this is my picture with Professor Joseph Wang, who developed this smart underwear. Unfortunately, military has abandoned this smart underwear. So in future, if it is not underwear, it can be any clothes which can detect, which have sensors to monitor soldiers' blood, sweat, tears for signs of distress. So helps can be sent as soon as possible. So in future, or right now, if we are to develop biosensors or chemical sensors, these are the characteristics which are simple, automated system, with rapid means that very fast results, a long storage life, accurate and quantitative results, definitely low cost so that everybody can use it, and it has to be with portable readout device, and much more preferred if we can pair it with our cell phone. And it is a bonus if we can detect multiple analytes at the same time. So in short, what people want, what industries want is cheap and cheerful devices. Cheap for everybody to pay, and cheerful means that it can work, it can detect many, and it gives you good results. If you are to invest in technologies, biosensor technology is one of the jackpot, one of the best investment. As you can see, by 2022, the biosensor market value can achieve almost 27 billion. And actually by 2028, it achieved 35 billion. And as you can see, based on the bar chart, that medical diagnostic, which is the point of care testing, home healthcare diagnostic, covers more than 50% of the biosensor market. This is SD Biosensor, a manufacturer of COVID-19 test kit in South Korea. This is one of the biggest supplier worldwide, and we in Malaysia have been using test kits from South Korea as well as from China. As you can see, this is the famous actor or a Korean actor, and this is their official ambassador. So you can imagine how profitable SD Biosensor has been for a while. And you can see there are many startups, okay, in development of biosensors. So this is actually a good investment, and based on the markets that I've shown just now, this is a very beneficial for future investment. Okay, and among the techniques that have been used in development of biosensor, as you can see, electrochemical is the one that most has been used in development of biosensor compared to optical, thermal, and piezoelectric. So before I proceed with what we have done for all these 20 years, I would like to introduce to you what is actually biosensors. So the first part that we have to know is when we say analyte is the one that we wish to detect. Be it virus, be it bacteria, glucose, cholesterol, or any other analytes that we wish to detect. And the most important component in development of biosensor is the bioreceptor or the chemical marker. Depends on whether it's biosensor or chemical sensor, depends on the molecular recognizing materials, whether it is biomarker or chemical marker. So as you can see, among the biomarkers are enzyme, antibody, microorganism, DNA, and other biomarkers. For chemical sensors, we can have chemical markers like peptides, or ligands, or ionophores, depends on what is selective towards the analyte. For the transducer, it is decided what kind of changes that you wish to observe. It can be based on current change, it can be based on color change, pH change, mass change. So based on that, we can decide which transducers, whether it's electrochemical or optical, piezoelectric, based on the changes that we wish to observe. And the last part, which is the most important one, is the reader. So what kind of reader or what kind of display that we would like to have for the whole biosensor devices. Well, I would like to share with you our work in development of TB biosensor. We have worked on TB biosensor since 2013. In 2019, 1.4 million people died from TB. This is according to WHO. We never learn from mistakes. For the past 5 years, TB, a respiratory disease, has remained the biggest infectious disease killer because the TB agenda consistently became less visible in front of other priorities. What does it mean? Because due to COVID-19, TB patients has been ignored, and sometimes they are not diagnosed. So we can see 5.8 million people reported to have access to TB care, down from 7.1 million in 2019. So that is a 4.1 million gap of people undiagnosed or not reported. So this is due to the COVID-19, and we are focusing and on COVID-19 and forgot about the TB cases. Why monitoring of tuberculosis is very important? Because actually 1/3 of global populations are infected with tuberculosis. And most people do not notice that they are infected with tuberculosis because sometimes tuberculosis infection can be latent. 10% will go on to develop active tuberculosis and probably the rest are not with symptoms. But unfortunately, if you are getting old and probably one day you will be immunosuppressed, then the active symptom will appear. So monitoring is very important. The key fact is TB is curable and preventable at early stage. As you can see, these are the countries that have a big burden on TB cases. They are India, Indonesia, China, Philippines, Pakistan, Nigeria, Bangladesh, and South Africa. And the one that we are afraid of is multi-drug resistant TB, MDR TB. Means that it is not responsive to a lot of drugs for TB treatment. So this is TB in Malaysia. I have statistics until 2018 and most cases are in Selangor and Sabah. So this is our health minister, current health minister, talking about TB deaths recently up to 5% due to drop in detection because the focus now is on COVID-19. So drug-resistant TB, DRTB, persists and threatens our health security. Malaysia will continue to strengthen latent TB screening and provide TB preventive therapy and ensure that DRTB is identified and treated appropriately, which I cite from a statement of Ministry of Health, Malaysia. So based on that, we have a collaboration with Idarius Sdn Bhd and Nano Malaysia Berhad. We have developed TB NanoSense, and you can actually look at the device in the YouTube, this YouTube link. And this is the basis of development of electrochemical TB detection. And we are using nano particle as one of the modifier. And we can, as you can see here, we have done clinical sample testing of the TB NanoSense, which is very important part in medical diagnostic devices development. And we are currently at a stage of larger clinical sample testing before any pre-commercialization activities can be done. We also work on aptamer antibody-based sandwich assay. As you can see, aptamer is a new types of biomarker, and we have actually achieved a very good observation in terms of specificity and sensitivity by using the aptamer. And this is an example of binary analysis for antigen, TB antigen, and aptamer. Apart from electrochemical technique, we have developed optical technique called plasmonic ELISA. The electrochemical technique probably is useful for common people. It's quite easy to use, but plasmonic ELISA is actually very useful for labs, okay, which requires testing for a large number of samples. By using ELISA, we can have multiple tests, minimum of 96 wells, and you can imagine how many samples can be done at one time. So the detection is based on color change of nanoparticle. And this is the example of what we have done with sputum samples from TB positive patients. And we have checked the selectivity of the techniques, and it works very well. With the help of Anglia Ruskin University in UK, under the grant, Newton Fund grant, Newton Unko Oma grant, we have developed an app to help to detect or to identify the color change, because we understand that by using naked eye is sometimes difficult to conclude the color, whether you have the right color for positive or the right color for negatives. So we developed together an apps to come up with an apps that can be used by using a mobile phone and can have a conclusion whether you have TB positive or TB negative. And this work has been cited in a lot of news in UK news. And the last one, which Malaysians are very familiar with, is the test strips. Okay, now people are very used to DIY, do-it-yourself test strip for COVID-19. So this is the basis of the test strip, and we have developed this test strip for TB detection. And the test strip has won gold in 2019 ITEX competition. And we have worked together with Sabah Anti-Tuberculosis Association Penampang branch to try to tackle their issues in TB cases. And unfortunately, because of the pandemic, the project has to be put on hold. So these are examples of the test strip testing on sputum samples, and as you can see, we have reproducible results and selective results in testing TB patient sample as well as negative samples. And based on this project, we were featured in a lot of news in newspapers, as well as we are featured in one of the documentary in RTM, Amazing Nano episode 9. I would like to share our previous work on dengue detection. We have done this in 2013 until 2015. So the first dengue detection that we have developed is based on resistance. And we are using silicon nanowire-based electrical biosensor. So as you can see, these are examples of a very nice silicon nanowire produced by our group. So this technique is based on DNA biosensor, and as you can see, we managed to differentiate between complementary target DNA as well as RT-PCR target DNA. And the second techniques that we use to develop dengue biosensor is by using electrochemical techniques. And here we have fabrication of silicon nanowires combined with gold nanoparticles modified electrodes. Based on these developed biosensors, we are able to test it on real sample detection, And this biosensor has showed an excellent discrimination of electrochemical signal between positive and negative samples. Apart from medical diagnostic related biosensors, we also work on agriculture related sensors. Why this is important? Because agriculture land are getting less. In 2015, the total land surface available in the world was 13.4 billion hectares. Out of this global land surface, only 1.5 billion hectares, which amounts to 11% of the globe's land surface, was used for crop production. So we can imagine that how this will affect our food supply. So in the point of view of an agriculture farm owner, the main requirements are listed here, but we only focus on disease detection. And the projects that we have is on the detection of Ganoderma boninense oil palm detection.
Oil palm is one of the most important plantation crops in Malaysia. Previous study shows export revenue of oil palm in Malaysia is about 61.4 billion ringgit. However, the oil palm faces the threat of a devastating disease caused by pathogenic fungus, Ganoderma boninense. G. boninense is a white rot fungus which rots and kills oil palm trees. The basal stem rot (BSR) and upper stem rot (USR) diseases lead to the severe decline of the yield and shorten the productive life of oil palm. The estimated yield loss due to BSR is up to 1.5 billion ringgit a year. University Putra Malaysia (UPM) has proposed a solution using nanotechnology for the effective and efficient detection and control of the pathogen under the Nanomite Research Grant. Main objective of this research project is to develop a complete solution for detection and control of Ganoderma boninense problem through smart farming, employing nanosensors and smart nanodelivery system. In general, Project 1 focuses on the study of specific markers for detection of G. boninense based on secondary metabolites, elicitors, and protein expressed upon infection, and the development of nanosensor for early detection of this pathogen in the host. Project 2 studies on the ineffectiveness of Ganoderma treatment due to the failure in delivering the fungicide to the disease location. The development of nanocarriers of agrochemicals with targeted delivery and controlled release capabilities have lately attracted considerable attention. Project 3 has found a certain method of detecting the specific DNA of G. boninense as an initial stage for agricultural diagnosis. The tool is Lab-on-Chip. This device comprises of two components: biosensor and microfluidic. Project 4 focuses on the implementation of the nanodelivery system in smart farming for actual detection and control of Ganoderma boninense.
According to the study by Malaysian Palm Oil Board, that the total estate affected is listed here and is getting, the disease keeps spreading by years and it is double in 5 years. So Ganoderma is the most devastating disease to the oil palm in Malaysia. It is caused by the white rot fungal pathogen Ganoderma boninens, which lead to basal stem rots. And this affect even the whole oil palm estates in Malaysia. Although it has been clearly identified as the main cause of the disease in oil palm, strategies for the early detection and control of Ganoderma boninens are still immature. Here I present the recent methods of detection of Ganoderma boninens, which is mostly based on analysis in the lab. And we have a very big bulky system to detect the infection of Ganoderma boninens. So we propose the use of e-nose, okay, electronic nose, for sniffing the infection of Ganoderma boninens in palm tree. So how does it work is because once the infection in plant surge, the release of metabolites as plant defense mechanism against plant pathogen interactions will happen. So the release of metabolites can be detected by using e-nose. So this is our e-nose. We call it versatile disease sniffer, and it is can be used coupled with mobile device for data collection. So it can use with a wireless connection to mobile for data collection, and you do not need to use laptop. So this work has been a collaboration with Nursery SDTC Saimdabi, which they allow us, Saimdabi SDTC has allowed us to use their nursery to test our e-nose. So this is when we did our testing using our e-nose to detect the possibility of using our e-nose to detect the infection of Ganoderma boninens. We also work with MPOB Keratung to use the e-nose in detection of Ganoderma boninens. So based on the external symptoms, so these are the stages of the infection for all palm seedlings. You can see the disease is classified from 0 to 4. And another way is by looking at the internal symptoms of all infected all palm seedlings, and can also be classified from 0 until 4. By using our e-nose, we can avoid destruction or sampling, destructive sampling. We can just use a specific plastic to avoid odor interference from outside. And from that, the odor can be analyzed by our e-nose. As you can see, the left side is the stages from stage 1 until stage 4, and the right side shows the discrimination by our e-nose from stage 1 and stage 4. So we are still developing this, and hopefully it can work by the end of this research on e-nose. And we also work on environmental related sensors. Okay, this is another example of our prototype, which we have developed for toxic metal sensors. An example of toxic metal sensors that we have worked on is mercury and cadmium ions. And there's quite a number of other toxic metals that we have worked on. So along the study that we have done for mercury, we have found out that the chemical marker that we use were able to remove mercury efficiently. So from here, we actually developed a removal system and managed to come out with a better technology compared to activated carbon. And from here, the journey begins, which we test with the oil and gas waste, because we know that mercury is one of the biggest problems in our oil and gas industry. So when we work together with HG Solutions Sdn Bhd, they managed to test our polymer, and we proved that we can reduce the mercury, as you can see, 80% reduction in a second. So this is me showing Datin Aini, where we work together with upstream, downstream, Sdn Bhd, who is one of the biggest service provider for oil and gas companies in Malaysia, showing that where we can put the polymer in. And we have been, the innovation have been featured in TV3 during the licensing agreement. So it's a journey because we have to go to meet them and understand their actual problem. So we have to go to Terengganu, we have to look at their setup and discuss with them. So it's not as easy that, as you can see, the journey has been tough. And apart from that, we also have food quality related sensors, and we have developed a portable biosensor for halal detection system, okay? And this is the basis of how we developed the DNA-based halal detection system. And we have tested it with, you can see, a real sample, as you can see, the bar chart below, and prove that we can, the DNA biosensor works, okay? And we also have developed electrochemical DNA biosensor for pathogen in food. In this case is Vibrio para. So the issue with Vibrio para is a pathogen in seafood samples, in, for example, in shrimp, cockles, seawater, tiger prawn. You can see these are amongst the ones that affected by Vibrio para pathogens. Okay, so this is the basis of development of DNA biosensor for detection of Vibrio para pathogen in seafood. And I would also like to promote my book, Biosensors and Chemical Sensors, a practical approach, where you can read all of our research developments in biosensors as well as chemical sensors. I would like to acknowledge a series of stakeholders, starting from University Putra Malaysia for IPB and IPS grant, MOSTI for Science Fund, a few Science Fund, MOHE for MRAN, Nanomites, FRGS, MITE for Newton Unku Omar Fund, Nano Malaysia Berhad, Nanomite Consortium, and our counterparts UNIMAP, USM Kubang Krian, Institute Perubatan Respiratory, Sabata Penampang, IDRIA Sdn Bhd, HG Solutions Sdn Bhd, Upstream, Downstream Sdn Bhd, and all our partners in UPM, which I cannot put here because there are so many. And I would like really to acknowledge this group, the Biosensors and Chemical Sensors Research Group, UPM Research Group, and all my lovely students. As you can see, they have received awards, they have graduated, and tears that they have after receiving results from Viva, okay? And along the way, they have attended competitions, and at the same time, who cannot come for convocation because of the distance between the countries and Malaysia, as well as those who has to postpone their convocation, and those who has bring happiness to the lab. With that, I say thank you, sekian, terima kasih.
Majlis merakamkan jutaan terima kasih kepada Yang Berbahagia Profesor Dr. Muhammad Roslan bin Sulaiman dan para sidang penonton. Dengan itu, maka berakhirlah sudah majlis syarahan inaugural pada hari ini. Majlis merakamkan jutaan terima kasih kepada Yang Berbahagia Profesor Dr. Muhammad Roslan bin Sulaiman dan para sidang penonton. Dengan itu, maka berakhirlah sudah majlis syarahan inaugural pada hari ini. Sekali lagi, majlis merakamkan ucapan terima kasih di atas kesudian anda semua yang mengikuti secara dalam talian. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. #stay safe, stay healthy. #kita jaga kita.